You know, just about every company today is sitting on an absolute mountain of data. But here's the billion-dollar question. How do you turn all that digital noise into actual, useful intelligence? Well, it all comes down to how you store and manage it. Today, we're going to break down the three core blueprints for modern data: the warehouse, the lake, and the real game changer, the lakehouse. This really hits the nail on the head, doesn't it? I mean, you can have petabytes of data from customers, from your operations, from sensors, but if you don't have the right system, it's all just static. See, the challenge isn't really about collecting data anymore. It's about choosing the right architecture to actually turn that data into answers.
All right, so to really get where we are now, we have to go back and look at the two classic approaches that kind of shaped everything. On one side, you've got the super structured and orderly data warehouse, and on the other, the vast, flexible data lake. Okay, let's start with the data warehouse. The best way to think about it is like a meticulously organized library. Before any book of data even gets put on the shelf, you have to know exactly where it's going to go. It uses this predefined structure with things called fact and dimension tables, which honestly is just a technical way of saying it organizes data into concrete events like a sale and all the context around it, like who bought it, when, and where. This makes it incredibly fast and perfect for business intelligence when you need reliable answers using good old SQL. Now, if the warehouse is that neat and tidy library, the data lake is a massive anything-goes storage locker. Seriously, you can throw everything in there: spreadsheets, JSON files, raw images, audio clips, you name it. There are no rules on the way in. The structure, or the schema, only gets applied when you decide to pull something out and analyze it. This schema-on-read approach is unbelievably flexible and really, really powerful for exploring. So let's put them side by side. The bottom line is this: a data warehouse forces you to have a strict plan when you store the data. That makes it super fast and reliable for business reporting on stuff you already know you need to track. But it really struggles with messy, unstructured data. The data lake, on the other hand, just welcomes all data types with open arms, making it the perfect playground for data scientists and machine learning projects that thrive on digging through raw, diverse data to find brand new patterns. For a long time, companies pretty much had to choose. Do we want the rigid order of the warehouse or the chaotic freedom of the lake? But this created a lot of problems, like data being stuck in different places and just a ton of complexity. So people started thinking, what if you didn't have to choose? And that exact idea is what led to the rise of the lakehouse. This is the question that really drove the whole next evolution in data architecture. I mean, what if you could get that super low-cost, flexible storage of a data lake, but you could also have the reliability, the performance, and the easy-to-use SQL features of a data warehouse? It sounds like the perfect solution, right? And here's the magic behind how it works. A lakehouse still stores all your raw data in a cheap data lake. But then there's this really clever technology layer that sits right on top of it. A great example is an open source format called Delta Lake. You can think of it like a transaction log for your data files. It basically adds all those nice warehouse-like features, like reliability and data quality rules, directly onto your lake. And just like that, all that messy data now looks and acts like clean, structured tables that you can query with SQL. It's the best of both worlds, for real. Okay, so we have these amazing data stores, but how does information actually get into them? Because the process of moving and preparing the data is just as important as the storage system itself. The modern way to do this, especially with lakes and lakehouses, is a process called ELT. That stands for extract, load, and transform. First, you extract the raw data from wherever it lives. Then you immediately load it in its original, untouched form right into the data lake. Now, here's the key difference. The final step, transform, only happens when you actually need the data for a specific analysis. This keeps the original data pure and gives you incredible flexibility down the road. All right, these concepts are great in theory, but what do they actually look like in the real world? To make this concrete, let's take a look at a couple of major services on Microsoft Azure that companies are using right now to build these powerful data platforms. So first up is Microsoft Fabric. You can think of this as Azure's big answer to the Lakehouse dream, a fully integrated all-in-one platform. It's designed to be a single environment that combines the data lake storage, a super high-performance SQL warehouse, and all the data pipelines you need to move stuff between them. So if you're looking to build a lakehouse without having to stitch together a dozen different services, Fabric is aiming to be that one-stop shop. Then you've got Azure Databricks.
This platform is built on top of Apache Spark, which is this massively powerful open source engine designed for processing just enormous data sets at incredible speed. Databricks is famous for its interactive notebooks, which makes it a huge favorite for data scientists doing complex analysis and machine learning. It's a fantastic choice if your organization needs a solution that can work across different clouds, not just Azure, or if your teams are already pros in the whole Spark ecosystem.
And this is a really important takeaway. It's not always an either-or decision. In the real world, complex data pipelines often use the best tool for each specific part of the job. For example, you might use a powerful Databricks cluster to process massive amounts of raw data in your lake and then load that nice cleaned up data into a Fabric warehouse so business analysts can easily run queries. They absolutely can and very often do work together. So, we've watched the world of data architecture evolve from these two totally separate paths into a powerful hybrid model. And that leaves us with a pretty fascinating question to chew on. Will one single all-in-one model eventually just dominate everything? Or are we actually heading towards a future of endlessly customizable hybrid solutions where we just mix and match the best tools for every unique data challenge that comes our way? Now that's something to think about.